Hi, my name is Suryanarayana. I'm a Java full stack trainer in IARE Engineering College, Dundigal, Hyderabad. Today, I'm going to explain you Java programming structure. Programming structure in Java. How Java program is structured from top to bottom. So this basic essential that every programmer who is doing programming in Java should know, because there are various parts in the Java programming. Like throughout the Java program, you can write comments anywhere, on the top, in the middle of the class, inside the constructor, inside the method, inside static block, inside non-static block, anywhere. Comments can be written anywhere inside the program. But coming to the Java program, if at all, if you want to declare package declaration to Java program, you must declare package declaration as the first statement. So that's how Java program is organized into 9 parts. The first one is package declaration. If you are interested to declare package declaration to class, you can declare it. Otherwise, it is optional. Package declaration is optional. Well, package declaration is essential because if you are planning to make your class reusable means accessible within and outside the directory. So, in technically we speak directory as a package. The group of collection of classes together, we call it a package. So, package, directory, or both are similar terms. So, in Java, we technically speak it as a package. So, if at all, if you want to make one directory class available or accessible outside the directory, outside the package, then package declaration is compulsory. So, for that, we'll have an example in the later sessions. So, package declaration is optional. If at all, if you want to declare, package declaration should be the first statement. The next to the package declaration is import statement. Import statements, package declaration is singular. Import statements is plural. You can import as many number of packages as you want. So in Java, there were around some 192 packages roughly exist. Only I'm talking about Java Standard Edition. Apart from that, Java Enterprise Edition, Hibernate, Spring, and various other frameworks, including probably might contain hundreds of packages and thousands of classes, multiples and thousands of classes. So if you want to make various other packages in our program, like for example in the core Java, we import java.lang. Most of the library covered in the java.lang itself, up to wrapper classes, exceptions, and threads will be covered in the java.lang package only. So after that, the IO streams, java.io package is required for IO streams for reading and writing into files. And the next Java.net networking package to write socket programming, UDP programming, we use Java.net package. And for the legacy API and collection API, if you want to use data structures in Java, like list, set, map, hash table, enumeration properties, in order to use these classes, we import Java.util package. So collection API we call it as Java.util package. So these are the mainly used packages from the Java Standard Edition. If you go to the advanced versions of Java, we import Java.SQL, JavaX.servlet, JavaX.servlet.http, JavaX.servlet.jsp. See, as you keep on developing the application, you will come to have a requirement of importing so many number of packages and their respective classes. And therefore, mainly for other package classes, we import statements. We import packages. So that is how import statements are important. So to make other package classes available in our class, we use import statements. And after that, the class declaration comes. So in the class declarations and access we'll see later. In the class declaration, we'll have mainly 3 major constructs: variable declarations, constructor implementation, method implementation. Variable declaration, constructor implementation, method implementation. These 3 are mainly inside class. And class also optionally contain static blocks and non-static blocks. And if at all if you want to write a class, then usually we require variable declarations, and in the class constructor implementation also usually exists. And if at all if class contains variables, the variables are initialized in the constructor, and where the variables are used inside the method. Okay? In the class, variable declaration, constructor implementation, and method implementation, all three are having one dependency another. If at all if you don't declare variable, you don't have a requirement of initializing them in the constructor. You may not be able to use it in the method implementation. So these three are interdependent. Static block and non-static blocks are optional. It depends on requirement we can use it. So altogether, if you see, the Java program consists of 9 parts. Comments, you can write anywhere in the program. Package declaration, if you want to declare package, it should be on top of the class. Then followed by import statements. You can import as a number of packages as you want. And as you keep on learning and practicing more number of Java programs, you will come to understand so many number of classes and so many number of packages. So the number of import statements will increase. And then next, but these three are optional. See, package declaration, import statements. If you don't want to make class usable, you don't require package declaration. If you don't want to use other package classes, you don't require import statement. But if you want to write a normal class, then class declaration, variable declaration, constructor implementation, and method implementation are mostly essential. And static blocks and non-static blocks are optional. So that we'll see at the end of the topic. Coming to the comments first. In Java, comments are of 3 types: single line comment, multi-line comment, documentation comment. These 3 comments are very, very simple, and comments are very, very important in the programming because whenever we develop application, we'll implement so much of logic. If at all if you are having a plan of implementing 2 to 3 different types of logics, so how do you make the previously written logic unused and recently written logic usable in the program? By using these comments only. If the statement want to be a single statement and that want to be unused, we will go for a single line comment. Suppose if you write a block of code, lines of code size, for example, 5 to 10 lines of code or 15 to 20 lines of code, that want to be remain unused in the program, and because we have written some other logic. So then what we'll do is we'll go for a multi-line comment. Documentation comment is completely different. Documentation comment is when you're writing a class, about the class, about the variable, about the constructor, about the method, about if you want to write anything, then you will write it in the documentation comment. In the next slides, we'll see with the examples. Single line comments. First of all, comments. Comments are the statements that are ignored by the compiler and interpreter. So if you write comments in the program, they will be mainly ignored by Java compiler, that I'm sure. So comments are used to provide explanation about why classes, why variables, why constructors, why methods, and why and how logic is written inside the method, and how the method is written, and why the logic is written inside the method. They're all described in the comments. So by reading comments, what benefit we get is others will understand about our code. Especially, see, writing comments about the class, variable, constructor, method makes our code understood by others, and as well as sometimes to us also. Suppose if you write a piece of code, if you write a class, you want to say, for example, 3 months ago, 6 months ago, 1 year ago, and next time when you visit, if you want to understand for what purpose I have written this class, the comment will briefly describe about the description of the class, the purpose of the class. So it not only makes our code understood by others, it makes our code understood by ourselves also. So that is how the comments are. The next, coming to the single line comment. Single line comment consists of 2 forward slash symbols. To write class name as a file name, most of the time, not most of the time, 100%, whenever I start writing a program, I first of all write class name in a comment. Class name as a file name in comment. Then I write class, same name as a file name. That is the class name. But first of all, whatever I want to name my class or I want to name my file, that I'll write it in the comment. Same name I'll use for both file name and as well as class name. So it's always a good practice to have the current file name in the comment, the current class name or current file name in the comment, not only in Java, in every programming. So to write class name as a file name, we'll write single line comment. In informal documentation, to describe about the following class, variable, constructor, and method. This is very, very important. If you want to write one line description about what the following variables, what the following classes, what the following constructors, what the following method is, that you'll write it in the comment, single line comment. And the single line comments are not only used inside the class or above the variable or above the constructor or above the method, even below the method, inside the method also. Inside the method also, for each and every line. Suppose if the line is above the normal variable declaration, means even sometimes why variable is declared and how variable we are initializing, why we are initializing that value to the variable, even to describe about that also. Inside the method, comment inside method to comment a single line such as variable declaration. Sometimes we want to declare a variable, but we want to comment it. We want to use some other variable in place of that variable, or we want to comment variable initialization, object creation, method calling, a return statement. Inside method, you can write, you can comment any line of code, any single line of code with a single line comment. If you want to comment multiple lines of code, then we'll go for multi-line comment. So to write class name as a file name, to write informal documentation about class, variable, constructor, and method. Inside the method, if you want to comment a variable declaration or variable initialization, object creation, method calling, or return statement. And in all these cases, we use single line comment. Coming to the multi-line comment. To write multi-line comment, we use forward slash asterisk forward slash. We use this for the multi-line comment. Slash star star slash. This is the common multi-line comment and single line comments used across in C, C++, VC++, and in Java programming languages. Other languages are having their own syntaxes. So coming to the multi-line comment, we use multi-line comment to comment a block of code in the method, such as not only a block of code, even inside the class. If you want to comment group of variable declaration statements, we'll go for multi-line comment. If you want to comment a constructor, we can put a constructor in the comment. And we have written a constructor, but we don't want the constructor. You can comment constructor. You can comment a method. A method is written with 5 lines of code. We are planning to write 10 lines of code method. So you comment previous method. Complete method or complete constructor or complete variable stack of code can be kept in comments. Inside the method also, we can put multi-line comment for commenting conditions, loops, exception handling statements, old method implementations. We use multi-line comment to comment any block of code inside the method also. Method we can comment. Inside method also, we can put comment anywhere. We can write multi-line comments in the below method implementation, or we can put unused logic in multi-line comment. For example, you take one simple for loop. For int a is equal to 0, a is less than 20, I plus plus. So this for loop is iterated for 20 times, 0 to up to 19, 20 iterations. So during each iteration, I value is produced by 0, 1, 2, 3, 4, and so on. So how do you write logic? That variable is even value or odd value. So I divided by I remainder of I modulus of 2 is equal to 0. Then I value is a even number. Otherwise I is a odd number. This is the usual logic written for determining whether the integer value is even value or not. I divided by 2. If remainder is 0, then I value is even value. Otherwise I value is the odd value. So that is the usual logic to find out whether the number is for the produced value, I value is a even number or odd number. So to find out and print that the variable is having a even value or not, we have employed almost 5 lines of code. If condition, SOP statement, floor basis else, floor basis SOP statement, and if condition close. 5 lines code we employed. Instead of employing 5 lines of code, this entire code can be written with a simple ternary operator. How to write ternary operator? I divided by 2, if remainder is 0, I divided by 2, if remainder is 0, what I am doing here is question mark. If the condition is satisfied, yes, this number is an even number. If the remainder is not equal to 0, we want to return this is an odd number. So this is an even number or this is an odd number. These two, any one of these statement will be returned to this variable underscore odd or dollar even. Why I named variable like this? Because to tell that in Java a variable can be begin or having an underscore and dollar symbols in the middle of the variable declaration. But a variable shouldn't contain multiple words separated with space separator, but a variable can be separated with underscore, dollar, small letters, capital letters. Ultimately, variable should be readable. So that's how I declared underscore odd or dollar even is equal to I divided by 2 if remainder is 0. This is an even number, otherwise this is an odd number. If the condition is satisfied, this is even number, otherwise this is an odd number. That statement will be written. Later on you can print the variable. And instead of writing 5 lines of code to determine whether integer variable is even or odd, we have written a single line of code, a single line of statement. So how do you comment previous code? We commented previous code using multi-line comment slash star star slash. Right? The next coming to the next slide. This is Java documentation comment. Coming to the Java documentation comment. Suppose I am implementing one small method called public int add. Add method takes two parameters, int I comma int j, two integer variables. So two integer parameters. Add int I comma int j, two integer parameters add method is taking, and it adds, it sums I and j and returns an integer value. So public int add int I comma int j throws illegal argument exception. So when I am implementing the method, it is very, very important that if the user do not pass a proper value, okay, I am expecting the add function, what I am expecting is, I am expecting two integer values. Both integer values must not be a 0 or less than 0. They must be above 0. Positive values. Suppose if user enters 0 or less than 0, minus 1, minus 2, minus 3, something like that. Sometimes if user wants to check whether the add method will add negative values or not, 0 values or not. Suppose if user passes any negative value or 0 value, what we want to do is, our intention is our method want to only perform addition operation on positive integer values but not on negative integer values. The point is very clear. So, but if user passes any 0 or less than 0 value, then what we want to do is we want to inform to the client saying that the arguments passed into the method are not correct arguments. So how do you express that the method passed the arguments are not correct arguments or not? So in Java, there is one predefined exception class exists with the name called illegal argument exception. Illegal argument exception. Whenever you are writing a method, you take some parameters and inside the method, you check whether the parameters are correct or not. If the method parameters are not correct, we write parameters, but user passes arguments at runtime. If the arguments are not correct, so we are having a privilege to throw illegal argument exception. Illegal argument exception clearly says that this method passed arguments are not valid arguments or not valid arguments. Actually, invalid arguments or illegal arguments, any one kind of exception we can throw, but invalid argument exception is not the illegal argument exceptions. So, if the values are, if I and j values are less than or equal to 0, we are throwing illegal argument exception. Otherwise, we are simply returning I plus j. It's a simple addition operation. But the user who are using add method wants to know that the two parameters must be non-negative and non-zero value. How do you tell? How do you tell to the user that these two method parameters are non-negative or non-zero values? So, on top of the method, we have written a documentation comment. How the documentation comment is slash double star asterisk forward slash star slash double star. This is the documentation comment beginning. Asterisk forward slash is the document end. So inside the documentation comment, for every line, we are putting one asterisk symbol. So the documentation comment, each and every line should be kept in the asterisk symbol, and it should begin with the asterisk symbol. Asterisk. The following method adds two integer variables and written integer. That is a brief description about the method. @author Surya, @version 1.0 since 5/1/2022. @param I is integer, @param j is equal to integer, @return integer, @exception the method parameter must be non-negative or non-zero value, otherwise illegal argument exception is thrown. Then whenever somebody reads this method, they clearly understand what this method is. The following method adds two integer variables and integer value. The point is very clear. Who wrote this method? Surya. And whether is this method implementation is a first time implementation or is it already an improvised version of the method implementation? It's a first version of the method. First time he is writing this method. So version 1.0. When did he wrote that method? 5/1/2022. What are the two parameters? I and j, both are integers. What is written about the method? Integer. And exception, at the rate exception. When exception comes if the method parameters are non-negative or non-zero value. Negative or zero value. Methods must be non-negative or non-zero value. That's what. If they are negative or zero value, then exception comes. So that is how on top of the method, the brief description is written about the method. And once after such a methods are implemented in a class, while compiling the class, how do we compile the class? We compile the class using Java C started Java or file limited Java. That is what the Java compilation. But to generate the documentation for these documentation comments, what we need to do is each and every class we must compile Java doc hyphen d dot started Java. Java doc hyphen d. Java doc command generates Java documentation. For what? For the started Java, for all the classes. So, but Java doc command asks where the classes are. Hyphen d, the directory we are specifying. Where the directory is current directory. And then Java documentation command, the Java documentation tool understand that all the .java extension files in the current directory want to be generated with the Java documentation. The Java documentation comments are written, they will be converted into HTML documentation. If you run this command, you will understand how the code is converted. So this is about Java documentation command. These are some of the tags used in the Java documentation. @order, @code, @deprecated. Suppose if the method became old, or if the method became outdated, and if developers don't want to use it, you can just put @deprecated in the Java documentation comment. Deprecated, if you put as a on top of the method, it indicates that the method became an obsolete, old, outdated, or maybe some improvised version of the method is implemented. So that's a previous method is marked as deprecated, @exception, @link. Suppose regarding our method or our class, we want to provide an external hyperlinks. Then we can add @link, and then followed by we can add that external hyperlink over there. @return, @since, @throws, @version. So these are some of the popular tags used in the Java documentation. So in the Java programming structure topic, comments are completed. Single line, multi-line, and documentation, Java documentation comments are completed. The next coming topic is package declaration and import statements. Package declaration and import statements are not compulsory to write a class in Java. To write a class in Java, class declaration, insert class variables, constructor, method, these implementations are compulsory. Package declaration and import statements are not mandatory. But when they are mandatory is because if at all a class want to be reusable, if a class want to be available outside our directory, in technical speaking, outside the package, then we need to declare package declaration. And in other directories, we must use import statements. Let's see with an example. Package name is a logical name to physically existing directory. Package name is a logical name to physically existing directory. There is no package as such, except all packages are directories itself. Physically existing directories are logically called as packages. Then, without directory, physically existing directory, we cannot name any package name. So that point you should always remember. So physically existing directory we must name as a logical as a package name. If class is written in one directory want to be used in other directories, if class written in one directory want to be used in other directories, then in every class in a directory, then every class in a directory must have a package declaration and class should be declared as public. If class is written in one directory want to be used in other directories, suppose for example in one directory, you are having some 4 to 5 classes. All 4 to 5 classes want to be available in outside the directory. Then what we need to do? In all the 4 to 5 classes, we need to declare current directory name as a package declaration. And all the classes should be declared as public. So, package declaration and public class declaration, these two combinations make class reusable and accessible outside the package. After all, if class is not declared as public or if package is not declared, class cannot be accessed outside the directory. That point is very clear. So variable constructors and methods can be declared with the desired scope. In public class, you can declare variable constructor and methods however you want with any access specifiers and modifiers. Such classes can be imported anywhere in the system. So we'll see with an example. Package declaration is meant if any user defined a class, Java class, want to be reusable within and outside the directory throughout the system, then package declaration is compulsory. Along with package declaration, the class also must be declared as public. That will see it's an example. Here is an example. So currently I am existing in C drive IARE. IARE is one parent directory. In C drive IARE, I've created a package name called, I've created a directory called core, and all cores of batch examples are placed in core directory. So for each and every batch, I'll declare one directory name called AM3, AM4, AM5 like that. And inside that AM3, for every topic, I'll create one folder called Java Lang, Java Evo, Java Net, Java it like that. Inside that Java Lang, we are having so many other directories like, for example, data types, conditions, loops, operators, arrays, and the next programming structure, object-oriented programming, exceptions, threads. We do a lot of, and we cover so many number of topics in Java Lang directory. So I named Java Lang in that because we are discussing Java programming structure example. I created one directory name called structure. It's just only for our sake, and for our demarcation sake. Java Lang structure. C IARE core in Java Lang structure. That is the directory name. Remember. So in this directory, I am creating one class called A.Java. A.Java. Class name is public class A. Class name is public class A. If at all, if you want to make any class reusable or accessible outside our current directory, so-called package, the first and foremost thing you must declare class as is public. If you don't declare class as public, non-public classes cannot be accessible outside the directory or technically speaking package. That's fine. Second point is our current directory must be declared as a package declaration. What is our current directory? See, we are in C drive IARE core AM3 Java Lang structure. Except that C colon IARE, that parent directory, we want to declare remaining directory core AM3 Java Lang structure. We want to declare remaining directory as a package declaration. Why I am declaring this entire directory as a package declaration? Because we'll include C colon IARE in the class path declaration. C colon IARE will update in the class path declaration. Once if you include C colon IARE in the class path declaration in system environment variable, the remaining core AM3 Java Lang structure remains as our package declaration. So wherever we go to other directory and we say import core.am3.javalang.structure.a, the class will be imported. And if you want to make classes reusable, current directory must be declared as package declaration. Class must be declared as public. Whatever we declare as a package, that parent directory must be updated in the class path. Once again, I am reminding you, if you want to make classes reusable, first class should be declared as public and our current directory should be declared as package. Up to whatever extent we declared as a package, its parent directory must be updated in class bug declaration. These three are very essential. If you don't declare class as public, or if you don't declare package declaration, or if you don't update package parent directory in class bug declaration, the class cannot be accessible outside the package. That's fine. And then next, coming to the class A, public class A. Inside public class A, I declare 4 variables. Because in Java, we are having 4 types of access specifiers: private, default, protected, public. So I declared one private int A variable, int B variable, protected int C variable, public int D variable. So these are private access specifier variable A, default access specifier variable B, protected access specifier variable C, public access specifier variable D. So, and even to spell that each variable, I have written comment here: private access specifier variable, default access specifier variable. And if you don't prefix any access specifier, it is by default default access specifier variable, and its scope is only within the package. That we'll see later. Protected variable and public variable. So inside this class A, I have written one method called print. The intention of this current example is to see how to declare 4 different access specifier variables. And if you declare variables as private, default, protected, and public, and how their access scope, we want to test how these different access specifier variables access scope is. In order to test that, I have written one method within the same class. In the same class A, I have written one method called print. In the print, I am trying to print ABCD variable. All ABCD variables are accessible because print is the method of the same class. So within the class, private variable can be accessible, default, protected, and public variables can be automatically be accessible. The next example is in the same directory. We'll write one more that we'll see later. After declaring package declaration and class as public, the package parent directory must be updated in the system environment variable class path. Otherwise, package and class cannot be imported in other directories. That is very clear. So the class exists in C colon IARE, core AM3 Java Lang structure is the remaining directory. This we maintained as a package, hence C colon IARE must be updated in the class path. Okay. So how packages can be imported in other directories? Import core.am3.javalang.structure.a. Like that we can import class A. So after completion of class A, within the class, we checked private, default, protected, and public variable access. All 4 variables are accessible. Now, in how many ways a class can be used in the object-oriented programming? I'm not only talking about Java, I'm talking about the generalized object-oriented programming. In every object-oriented programming language, in how many ways a class can be used? A class can be used in 2 ways. One is by doing inheritance, one is by instantiation. Okay? A class can be inherited or a class can be instantiated. Okay? A class can be subclass. Okay? A class can be act as a parent and it can be derived into subclass, or a class can be instantiated. So when to go for inheritance, when to go for instantiation, the consequences we'll see later on. Okay. So the next coming to here, write a subclass of class A within the same package. Write a subclass of class A within the same package. In the same package, I'm writing one more class called b.java. Same package declaration. Public class B extends A. Public class B extends A. B and A both are in the same directory, and both are having same package declaration also. So now B can be derived from A. In the B class, I am writing one method called print, and in the print method, I am trying to print ABCD variables. Because A is a private variable in class A, private members can be accessible only within that class, but cannot be accessible in subclasses or anywhere outside the class. So because A is a private variable, except a private variable, all other variables are accessible. B, C, D, all other variables are accessible. Private variables are restricted to be accessed only within the class. Default, protected, and public variables can be accessed in the subclass within the package. In subclass within the package, except private member, all other members are accessible. What is the next way of making the class usable is by instantiation. So in the same directory, I'm writing c.java. The same package declaration, public class C, public void print. In the print method, I'm instantiating class A. A is equal to new AF. A is equal to new AF. A class is instantiated. A dot B, A dot C, A dot D. And with the object dot, A, B, C, D variables are accessible. All four variables are accessible. Are they accessible or not? In the instantiated class, except private member, default protected and public members are accessible. Default members are accessible up to within the package. Private members are accessible only up to the class. That's why A cannot be accessed. B can be accessed both in subclass and instantiated class because both B and C are in the same package. Within the same package classes, the default specifier member can be accessible. So below I've written, I think. So in instantiated class within the package also, except private member, all other members are accessible. So C instantiates class A. Instantiated class A. So here, except A, B, C, D, all three variables are accessible. Similarly, same as B and C, a subclass and instantiated class within the package, we'll go to outside the package. In the outside of the package, we'll write one subclass of A, we'll write one instantiated class of class A, and we'll see how far this private default protected and public member variables can be accessible. So coming to the D. So we change the directory C colon IARE core AM3 Java line. Previously that is structure. This first. We went to some other directory. And then we changed the directory. We went to some other directory. D.java. There we want to import class A. How to import? Import core dot AM3 dot Java line dot structure dot A. A class is imported because its parent directory is already updated in class path remember. This is declared as a package declaration over there. Class is also declared as A. All three conditions are if not satisfied, class A cannot be imported up to here. So that point is very clear. The next public class D extends A. So what D class is? D is a subclass of class A outside the directory or outside the package. D is a subclass. Now we write a subclass of class A outside the package. D is a subclass of class A outside the package. Outside the package class means private member cannot be accessible. Private member cannot come. Second one is B is a default access specifier variable. A default access specifier variable can be accessible only up to the classes within the same package but not to outside the package. D though is a subclass of class A but outside the package. Private member cannot come. Default member cannot come. Only protected public members can come. So default members can be accessible within the class, subclass within the package, instantiated class within the package, but not outside the package classes. Default members cannot come. There is a restriction. But protected and public members can come. Protected and public members can come. Especially one more important point we should notice here is protected member can come only up to subclass outside the package. Okay? Protected members last scope is this scope. Up to how many scopes are completed within the class, subclass within the package, instantiated class within the package, 3 scopes are completed. Subclass outside the package, it's a 4 scope. So protected member can be accessible up to subclass outside the package. This is the last scope. Protected member cannot be accessible beyond this scope. What is the beyond this scope? What is the next scope? So D extends A. The next coming class E. E instantiates A and tries to access its ABCD variable. Private member cannot come. Default member cannot come. Even protected member also cannot come to instantiated classes outside the directory. Then which access specifier member can only be accessible anywhere within the system is only public. Public is the final winner. In subclass outside the package, private and default members are not accessible. Only protected public members are accessible. Default members cannot be accessible outside of the package. The point is very clear. Now coming to E. Outside the directory. E.Java instantiated class A outside the package. Here also we are importing class A, public class A, print method. Here we created object of A. With the object of A variable cannot be accessible because A is private. B variable cannot be accessible because B is a default accessible variable. C cannot be accessible. C is a protected member. Protected member can come only up to subclass outside the package but not to the instantiated class. Only public member can be accessible anywhere. In instantiated class of outside the package, except public, no other members are accessible. In this session, we understood package declaration, import statement, and more importantly, access scope of access specifiers, private, default, protected, and public. One just brief review. Access specifier and their scopes. Variables declared as private can be accessible only within the class, but not a subclass and instantiated class within and outside the package. No. Default access specifier member can be accessible in both. Default access specifier member can be accessible both in subclass and instantiated class within the package. Within the package, that is the condition. Within the package. Default member. Protected member can be accessible within the class, subclass and instantiated class within the package, and only up to subclass outside the package. That is the last scope to the protected member. Protected member cannot be accessible in instantiated class outside the package. Okay. So anywhere within the package and only up to subclass outside the package. Okay. Public member variables can be accessible both in subclass and instantiated class within and outside the package. And the public member is having all 5 scopes within the class, subclass and instantiated class within the package, subclass and instantiated class outside the package. Good. So this diagram shows. This diagram shows private variable. Private member can be accessible only within the class. Yes. Within the package, subclass and instantiated class, private member, no. Outside the package, subclass and instantiated class, private member can be accessible, no. Default member can be accessible within the class. Within the package to subclass and instantiated class, yes. Default member can be accessible up to subclass and instantiated class within the package. And outside of the package, default member cannot be accessible both in subclass and instantiated class. Protected member can be accessible within the class, subclass within the package, instantiated class within the package, subclass outside the package, but not an instantiated class outside the package. Public member within the class, subclass within the package, instantiated class within the package, subclass outside the package, instantiated class outside the package. So public member can be accessible to all the scopes. This is access specifiers and their scopes. And in the next slide, slide, we specified on what we can apply private, default, protected, public. So as I told you, a Java program mainly consists of class, variable, constructor, method. Class, variable, constructor, method. So to which private, default, protected, and public access specifier can be accessible. Private can be assigned only to variable, constructor, and method, but not to class. Class cannot be private now. Class members can be private. What class members are? Variables are class members. Constructors are class members. Methods are class members. Only class members can be declared as private. Class cannot be declared as private. That point is very clear. VCOM, variable, constructor, method. Coming to the default. Default access specifier can be applied on class, variable, constructor, method. Class can be declared as default. Suppose if class is declared as default, it cannot be accessible outside the package. Though package declaration exists. That we'll see later. Class variables can be default, constructors can be default, methods can be default. Coming to the protected. A protected can be applied only on protected cannot be applied on class this is not valid, only to public. Protected can be applied only to variables, constructors and methods, but not to the class. Okay, to class we cannot apply private and protected. We can apply only default and public. So protected cannot be applied on class. Okay, only to variables, constructors and methods. Public can be applied right from class to variable, constructor and method. Okay. So private only on class, variable, constructor. Private only on variable, constructor method. Default class, variable, constructor method. Protected only variable, constructor method. Public class, variable, constructor method. All four. Coming to the modifiers. In Java, we are having altogether 3 plus 2, 5 plus 2, 7 modifiers. Abstract, static, final, transient, volatile, native, synchronized. 7 access modifiers. Access specifiers restricts the scope of a variable or constructor or method within the class or within the package or outside package. They restrict the scope of accessing. Modifiers are completely for different purpose. In the next topic, we'll discuss about modifiers. Coming to the modifiers also, abstract can be applied on what? Abstract can be applied on class and method, but not to variable and constructor. Abstract cannot be applied on variable. Abstract cannot be applied on constructor. Abstract can be applied only on class and method. Abstract class, abstract method. Right. Coming to the final class, final construct, final variable, final constructor. On constructor, we cannot apply any modifier. And method, final method, yes. Final can be applied on class, variable and method. Okay. The next is static. Static cannot be applied on class. Static can be applied only on variable and method. Static can be applied only on variable and method. Okay. Coming to the transient. Transient and volatile can be applied only on variables. These two, transient and volatile access modifiers, can be applied only on variables but not on classes. And coming to the last two modifiers, native and synchronized. Native and synchronized can be applied only on methods but not on class, variable and constructor. So that's all. Abstract on class and method. Final on class, variable and method. Static on variable and method. Transient and volatile only on variables. Native and synchronized only on methods. These are the access modifiers topic. Access modifiers and which modifiers and specifiers we can apply on class, variable, constructor method was explained in this slide. In the next session, we'll see this. To variable, what we can apply. Access specifiers, modifiers. To variable, private, default, protected, public. Access specifiers. Modifiers, final, static, transient, volatile. Okay. To constructor, applicability, private, default, protected, public. All four can be applied. Specifiers on constructor. On coming to the modifiers, to constructor, we cannot apply any modifiers. To method, we can apply all access specifiers, private, default, protected, and public. Modifiers, we can apply abstract method, final method, static method, and native and synchronized methods. To method. To class, default and public access specifiers only can be applied. To class, only modifiers, abstract class and final class. Only two modifiers can be applied to class. This is all about which access specifiers and modifiers we can apply on class, variable, and constructor and method. But not their consequences are not discussed. The consequences will be discussed in the next topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.